Okay, this video is about finding the points of intersection using simultaneous equations. When we have nonlinear, nonlinear, I'm talking about x squared, x cubed, anything that's not x, square root of x, any of those, we use substitution as a method to solve for x and y. We avoid the elimination method because it may also eliminate some of the solutions. So let's put that into practice. Here we go. Find the coordinates of the point of intersection on the parabola y equals x squared minus 2x minus 2 and the line y equals x plus 4. So y equals x squared minus 2x minus 2 and y equals x plus 4. So you can already see both of the equations are equal to y. So we can make the two equations equal to each other. So I'm going to substitute equation 1 into equation 2. So x plus 4 equals x squared minus 2x minus 2. Let's take everything over to, so subtract x, subtract 4. So x squared minus 3x minus 6. Okay, so to solve this, I'm going to use the quadratic formula. So you might remember, to use the quadratic formula, I'm going to say a equals 1, b equals minus 3, c equals minus 6, and I'm saying x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I'm going to keep going. So just a bit more space here. Okay, so x equals minus 3 plus or minus 3 squared minus 4 times 1 times minus 6. I want the square root of all of that, and all of that over 2 times 1. And that gives me 3 minus a minus plus or minus 9 minus 4 times 3, 4 6 is 24, plus 24, minus times a minus, all over 2. So I end up with x equals the square root 3 plus or minus square root of 33 over 2. Now I'm going to leave it as an exact value. Now, go back up here, let's find this equation, y equals x plus 4. I'm going to substitute that into, so it's up here, let's substitute, x equals 3 plus or minus square root of 33 over 2 into equation 2. And so y equals 3 plus or minus square root of 33 over 2 plus 4. Let's put it all on the common denominator. Plus 8 over 2. 3 plus 8 is 11 plus or minus root 33 on 2. Now what do we have? We've got 2 x's and we've got 2 y's. and we need to put them together. So our coordinates become 3 plus root 33 over 2 and 11 plus root 33 over 2. You can make them decimals, but we try to keep them as exact values if we can. And the other coordinate would be 3 minus root 33 over 2 and 11 minus root 33 over 2. And so there, this particular set of equations intersect at 2 points. Okay, let's do one more. So number 2, find the coordinates of the point of intersection, or points of intersection, of the circle x minus 4 all squared plus y squared equals 16, and the line. Again, we're going with our equation. X take 4 all squared plus y squared equals 16. That can become equation 1. X minus y equals 0. That can become equation 2. I'm going to rearrange equation 2. To become y equals to x. So that's my 2 star. I've just rearranged it. And I'm going to substitute. So substitute 2 star into equation 1. So equation 1, x minus 4 all squared plus x. I'm substituting x equals y. So instead of y, I'm putting x. Equals 16. Okay, a little bit of algebra now. Let's expand this bracket. X squared minus 2 times 4 times x, so that's 8x plus 16 minus 4 times 4 plus x squared equals 16. Plus 16 on both sides, minus 16 cancel out, so we're going to end up with 0 on this side. We're going to have 2x squared minus 8x. Take 2x out as a common factor. X minus 4 equals 0. So 2x equals 0. Gives me x equals 0 and x minus 4 equals 0. So x equals 4. So two solutions, x equals 0, x equals 4. We'll go back up to the original equations and you can look at this one here. You can say, well, equation 2 star, y equals x. So when we substitute x equals 4, our coordinates become, when x equals 0, y equals 0. When x equals 4, y equals 4. Okay, so basic rule here, remember, when you've got nonlinear equations, substitute.